Section 7.3 has to do with the law of cosines. So we've been dealing with the law of sines, which is pretty straightforward. We're using proportions. Law of cosines, if you have all three sides, then you can use law of cosines. And a squared equals b squared plus c squared minus 2bc cosine a. Now, you may think you'd never remember that, but if you have a squared here, then you've got your A angle here. If you have B squared, you got B, C squared, you got C. And the other letters take up over here. So if you're A here, you've got B squared, C squared, and 2BC. If you've got B squared, you got A squared plus C squared. You see where I'm going with that. So let's see how we work that formula. So in example 2, so you are given angle A is 42.3 degrees. Side B is 12.9, side C is 15.4. So what we do know, if we're going to solve for side A, we can use the law of cosines for that. So A squared equals B squared plus C squared minus 2BC cosine A. Then you're just filling in all the numbers that you do have. There's some squaring, there's some calculator work. A squared is 109.7, so A is 10.47. Once you have that side, you can use law of sines to get the rest of your items that you need for the triangle. So once you get down to here and sine B is equal to this, you plug that in, you get a 0.89 with a lot of digits. Do second sign of that answer and you get 56.017. And so we have solved the triangle by using law of cosines and law of sines. And that's what we'll probably be doing in our problem set. Let's go check that out. There is one more formula that we're going to need to work our problems, and I omitted giving that to you. Heron's area formula. So if you're given three sides of a triangle, you can find the area of that triangle. We're used to doing area with 1/2 base times height, and we don't have any of that in some of these. So we need to first get a semi-perimeter. So the three sides that you're given, you add those together and then you take half of that. That gives you the semi-perimeter. That's your S. Then the area is the square root of S times S minus A times S minus B times S minus C. So if you just have the formula handy, you can do some plugging in. So now let's go look at problems. We'll go to the top here. Find the exact length of the unknown side. Do not use a calculator. All right, well, when we see 60 degrees, that means we could find out some things because we know those basic certain angles. So if I'm trying to find side A, I use my law of cosines, and here's my formula that I would want to use. I plug in everything I know, and including the cosine of 60 degrees. I don't have a calculator, but the cosine of 60 is 1/2. I square this, that's 64 plus 25 minus 2 times 5 is 10 times 8 is 80. Half of that, so you have 89 minus 40. A squared is 49, so A is the square root of that, which is 7. Same thing for number 2. You have angle B that you're supposed to find. So we're solving for angle B, so we will say B squared equals, and we'll have this, and we'll be able to fill in everything except angle B. So 28 squared equals, plug in all of the pieces, and you're left with cosine B. Now you do have to be careful on this because all of this is adding, and you get the number 400. Then you have 400 plus 144 minus the 480 actually stays right here. So we've got 544 minus 480 cosine B. We're going to subtract the 544 and we're left with 240 equals negative 480 cosine B. we divide this because it's being multiplied here. So all of this is separate. This is attached to the cosine b. When you do that, you get negative 1/2 equals cosine b. And so you're finding out, where is cosine negative? Quadrant 2 or quadrant 3? Well, quadrant 3 would be more than 180, so it can't be there. So in quadrant 2, the angle that has a 1/2 as its cosine would be a 60-degree reference, and so that'd be 120. That will be angle B. Number 3, solve the triangle shown to the right. So we're going to first start out and try to get side C, and that's the thing that we don't have. And so C squared, I did that, plugged in everything else, and we ended up with C was 6.0. Once you get that, you can find the other two angles by using the law of sines. So that's what I did here. Plugged in what I had, and I got sine A is equal to this, which would then be 0.83130. Second sine of that gives you 56.2. And I think they're saying do not round to the final answer, then round to the nearest tenth. That's in this first part. In these, it's the nearest degree, so 56. And then you add 56 and 94, subtract from 180, you get 30. So you're using law of cosines first and then law of sines. In this triangle, we're supposed to find side A and angle B and angle C. It's the exact same thing. We're going to use A squared equals this. Plug in everything you get. You end up with A squared's 255.132. And the square root of that is 15.97. It says round to the whole number, so that's 16. 180 minus, well, no, I can't do that yet. Then I used the law of sines to get side B, made it a whole number, which was 17. And so then I had 180 minus 17 plus 31. That gave me C, angle C is 132. So you filled out all three parts. Number 5, we're omitting. Let's go to number 6 and do some area. So you're given A, B, and C, and they want to know the area of the triangle. So the first thing we had to do was find the semi-perimeter. So you add up all three sides, divide by 2. That's 23. So then the formula is the square root of 23 times 23 minus that side, 23 minus that side, 23 minus that one. And you'll get some numbers in here. You can do all of that in your calculator, and you get 84.7 if you round to the nearest tenth. Number 7, same idea. Got some big numbers there. The semi-perimeter it becomes 144.45. So you just got some big numbers, but you're taking the square root of this business, and you should get 3923 for your area. So just using the law of cosines along with the law of sines to help you solve triangles, and then use Heron's formula for the area.